So let us see the question number 51. So consider the waveform. Okay. So consider the waveform cos 2 pi f1 t plus theta and cos 2 pi f2 of t theta. F1 is greater than f2. You can see down also. Okay. So two waveform is given. So that is what non-coherent binary FSK signal. Two non-coherent binary FSK signal is given. Okay. Non-coherent binary FSK signal. Okay. So this is what S1, S2. Like S1 of T, two signal is given. So this is non-coherent binary FSK signal. S1 of T is what? Cos 2 pi F1 cos 2 pi F1 T plus theta, and S2 is given as S2 of T is equal to what? Cos 2 pi F2 of T. Yes, these two signal are given. Yes, these two signal are given here, and here F1 is what? F1 is greater than F2. Okay, F1 is greater than F2. This is given two. Okay, two signal. Both are what? Non-coherent binary FSK signal. Okay, binary FSK signal, and theta here, theta is varying from 0 to 2 pi. Okay, so arbitrary constant. Okay, so arbitrary constant angle from 0 to 2 pi. So, and what is the minimum separation required between, what is the minimum separation that is required between F1 and F2? Okay, for non-coherent orthogonal FSK, for non-coherent orthogonal FSK. Okay, so what is the minimum separation? What is the minimum separation required for the non-coherent FSK orthogonal? Okay, so for non-coherent orthogonal FSK, what is the minimum separation? Okay, so see, these are the two what? Two symbol. Okay, which we are transmitting from what? Transmitter. Okay, in free space, through which technology? Through the technology of FSK. Okay, frequency shifting technology. Okay, so here we are using what? Where we are sending two signal. Okay, which have different frequency, F1 and F2. Here F1 is what? Mark frequency, and F2 is space frequency. Mark and space frequency, two frequency which both are different. Okay, both are different, and we are transmitting the signal from transmitter through space. Okay, to space. Okay, so this signal is transmitting. Okay, so through the space. Okay, so two signal. So F1 and F2 are, F1 is mark frequency, F2 is space frequency. F1 is greater than F2, and asking what is the minimum separation between F1 and F2, so that these two non-coherent signal are orthogonal. Orthogonal means both are 90-degree to each other. Okay, so then there is no distortion, yes, in the signal. Okay, so we will receive the signal properly. Okay, properly, and there is no loss of information. For that purpose, these two signal must be orthogonal. The condition for orthogonal is what? Condition for orthogonal is nothing but integration what? Integration 0 to t. Yes, condition for orthogonal is nothing but integration 0 to t, that is area under, yes, multiplication. So multiplication of these two signal must be what? Must be under 0 to t over one period, s1 of t into s2 of t must be s2 of t dt is equal to what? 0. Okay, is equal to 0. This is what? This is the condition for orthogonality. Okay, so total area must be equal to what? 0. Total area must be equal to 0, and this is the condition for orthogonality. Okay, if these two signal are orthogonal, then there is no chance of overlapping. Okay, overlapping of information means we will not lose any information. Okay, if we apply this rule. Okay, orthogonality. Okay, both are non-coherent signal. So here F1 and F2 are mark and space frequency. Okay, so just solve this. We will get what? 0 to t s1 of t is what? Cos 2 pi f1 of t plus theta into cos 2 pi f2 of t, yes, cos 2 pi f2 of t dt. dt is equal to what? 0. Okay, so now see here, cos a cos b, cos a cos a, cos a cos b, just multiply and divide by 2, so we will get 0 to t, 0 to t. So this is 2 cos a cos b, so it is cos a plus b, cos a plus b. So this is 2 pi f1 plus f2 into t plus theta. Yes, cos a cos b, cos a plus b. Okay, cos a plus b plus cos a minus b. So this is nothing but 2 pi f1 minus f2 into t. Okay, so cos a minus b, cos a minus b, cos a plus b, cos a plus b plus cos a minus b. Yes, cos a minus b, just theta. Okay, so this is what? This is dt. Okay, cos a plus b plus cos a minus b. So now see, we are going to integrate this. When you will integrate, so this must be equal to what? 0. So when you will integrate this, what we will get? So see here, cos integration is what? Sine. So this is sine. Okay, just put here limit, upper limit. Okay, so just put this upper limit and lower limit. What we will get? 0 to t. So upper limit is what? Upper limit is sine. So this is upper limit sine 2 pi f1 plus f2 sine 2 pi f1 plus f2 t plus theta. Okay, so divided by 2 pi f1 plus f2. Okay, f1 plus f2 plus sine 2 pi f1 minus f2 into t. Yes, capital T plus theta divided by 2 pi f1 minus f2. Yes, f1 minus f2. So this is my what? This is my upper limit minus lower limit is what? 0. Just put 0 here. If you will put 0 here, sine 0 will become 0. Yes, there is only sine theta. Yes, there is only sine theta. So this is sine theta. There is only sine theta. If you will put here 0. Okay, so this is just like this. Yes, sine theta divided by 2 pi f1 plus f2. Yes, upper limit minus lower limit. This also sine theta divided by 2 pi f1 plus f1 minus f2 is equal to what? 0. Okay, so now just we have to make both of this is equal to this will become equal to what? 0. This is equal to this will become equal to 0. We have to make both is equal to 0. So just focus on this part only, f1 minus f2. Okay, so value will also come here, f1 plus f2, but this is not required for the answer. Okay, so just focus on this part only. So therefore sine 2 pi f1 minus f2 t plus theta. Okay, t plus theta minus sine theta divided by 2 pi f1 minus f2 is equal to what? 0. Yes, is equal to 0. One equation you have to put is equal to 0 and other one is what? This is my first part. Okay, second part you can put this sine 2 pi f1 plus f2 capital T plus theta minus sine theta divided by 2 pi f1 minus f2 is equal to what? 0. Yes, is equal to 0. So you have to put both part is equal to what? 0. Okay, so this is first part. Yes, this is my first part and this is my second. Yes, so this is my second part. Okay, So you have to put both equal to 0. So like this. Okay, so now see here. So just I am going to rub this from here. So now finally what we will get the difference. Okay, so let us see, focus, what we will get the difference. So this is my second part. Yes, so both we will put is equal to 0. First is what, this sine 2 pi, sine 2 pi, 2 pi f1 minus f2, sine 2 pi f1 minus f2 into t plus theta plus theta plus theta plus theta minus sine theta is equal to what, 0, is equal to 0. And second part is what, sine 2 pi f1 plus f2 into t plus theta minus sine theta is equal to what, 0, is equal to 0. Just wait. Okay student, I think it is not visible. Okay, so now it will be visible. Okay, so f1 minus f1 plus f2 into t plus theta is equal to what, theta minus sine theta. Okay, so this is theta sine theta is equal to what, 0. Okay, so now see, these are two equations, so that we are going to make 0. Yes, f1 minus f2. Okay, so in order to make both signal as orthogonal. Yes, why orthogonal? Because if both signal are orthogonal, then what, there is no interruption of signal and there is no loss of information actually, and we will properly receive the signal from transmitter to receiver. Okay, so there is much low minimum losses. Yes, that may be due to because of other, but so this is the condition for what, this is the condition for orthogonality. Yes, orthogonality. So now let us put both is equal to 0. So we have make both is equal to 0. So when these two are 0, so then it is only 0 when sine 2 pi when sine 2 pi into f1 minus f2 into t plus theta is equal to what, is equal to sine theta. Yes, is equal to sine theta. Yes, when both are equal to what, when this is equal to this, then this whole will become equal to 0. And also sine 2 pi f1 plus f2 into t plus theta is equal to sine theta. Yes, is equal to sine theta. So both should be equal to sine theta. So then only it is possible that this product is equal to 0 and this area is equal to 0 and both signal are orthogonal. Yes. So now what we will do now, so just rub this. Okay, so we are coming closer to the answer. So this is what, so this is my condition. Okay, so let us put this sine theta. Okay, so this is like this bracket. Okay, so big bracket, so this is inside bracket. Okay, so now see here, as we know very well sine 2 pi n. Okay, so sine 2 pi n plus theta is equal to what, is equal to sine theta. Yes, that we know very well. Yes, for n not is equal to what, 0. For n not is equal to 0. Why? Because f1 is not is equal to f2. Okay, so but here f1 is greater than f2. Okay, so n should not be equal to 0 according to this. For this n should not be equal to what, 0. for this n should not be equal to 0. Why? Because both frequency are different. F1 is mark frequency, F2 is space frequency. So F1 is greater than F2. Okay, F1 is greater than F2. Mark frequency is greater than space frequency. So now for this, what we can say that from this and from this, compare this with this. This left side is equal. Okay, so this left side is equal, and this should be equal. What equal? This will be equal when 2 pi f1. Yes, when 2 pi f1 minus f2 plus theta, f1 minus f2 into t plus theta is equal to what? Is equal to plus theta. Okay, so plus theta is equal to, so let us just write it above. So this is what? F1 not equal to F2 and F1 is greater than F2. Yes, so this is the reason for this. Yes, so this is 2 pi F1 minus F2 into t plus theta is equal to what? 2 pi n plus theta. Yes, here theta will get cancelled. Yes, theta will get cancelled. So then we are left with 2 pi F1 and 2 pi F1 plus F2 into t plus theta is equal to what? 2 pi n plus theta. Yes, theta will get cancelled from here also. Okay, so we are now left with what? 2 pi F1 plus minus, we can see F1 plus minus F2 I am writing for both simultaneously. Okay, so F1 plus minus F2 is equal to 2 pi n. So 2 pi get cancelled. Okay, so from here what we will get? F1 plus minus F2 is equal to what? Is equal to n. Yes, so this is what? N. So this must be the final value, and this n minimum is equal to what? 1. N minimum is equal to 1. So therefore F1 plus minus F2 is equal to what? F1 plus minus, sorry, here F1 plus minus F2 into t is equal to what? N is equal to n. So this is F1 plus minus F2 into t is equal to what? Is equal to 1. So therefore F1 plus minus F2 is equal to what? 1 by t, and hence we can write the answer as what? This. Okay, so this one is the final answer. F1 plus minus F2 is equal to 1 by t, and here you can write final answer for this. Final answer is what? F1 minus F2 is equal to what? 1 by t. So the space between these two frequency, or separation between these two frequency, must be equal to 1 by t. And also F1 plus F2, that also must be equal to 1 by 2. Yes, but okay, so both of these must, that sum and difference both must be equal to 1 by 2. So this is the answer for this. Yes, F1 minus F2. Okay, so when F1 minus F2 is equal to 1 by t, so then only these two signal are orthogonal, and hence we will achieve the orthogonality condition for two non-coherent FSK signal. Okay, so non-coherent FSK signal. So this is the condition. Okay, F1 minus F2 is equal to 1 by t. So therefore the option A is correct. So option number A is correct for question number 50. Yes, this is question number 50. Yes. So that's all for this question. Let us move to next question.